Hello students, welcome to Narayan PU College online classes. So we are discussing about the competitive. In the last video we have completed level 2 up to the 4th question. So now we will go for the 5th question. See now what the question they have given here. ROH react with SOCl2 in presence of pyridine. Clear? So it gives here RCl plus SO2 plus HCl. RCl, SO2 plus HCl. So here they are asking pyridine in the above reaction is. In the above reaction, what is the role of pyridine? So the role of pyridine in this reaction is a catalyst. So we will use the pyridine as a catalyst, and also in the reaction acid is formed. So to neutralize that acid, and this is a acid, pyridine is a base. So both, and this pyridine use it to neutralize the and HCl which is generated in this reaction. So what is the option here? Option 1 is the correct one. Clear? Use it as a catalyst. So next one, question number 6. Reaction of alcohol does not show cleavage of RO linkage. Does not show cleavage of RO linkage. See the first question. So what it is? ROH, we have already discussed PCl5 reaction with the alcohol and generates alkyl halides. You will get here RCl plus, what is the reaction? POCl3 plus HCl. So which bond cleavage takes place here? RO. And OH is removed and Cl has been introduced. So that's why what it is the reaction here? CO cleavage, RO cleavage here. And next one also, ROH plus SOCl to Dodgen's process, you already know. What is the reaction? RCl plus SO2 plus what you will get? HCl. Clear? Here also which bond breaks and RO cleavage takes place here. OH is removed, Cl is introduced. And next one here, ROH plus HCl. Here also which bond breaks? You already know. And RO bond is breaking, and you will get RCl plus what you will get? H2O. And last question, last option here, ROH plus what it is here? Na. When alcohol reacted with the metals and they forms alkoxide. So what is the alkoxide here? RONA plus of H2. This is the reaction. So in this case, the bond here, which bond breaks? OH bond, but not RO bond. So that's why this is the answer. So they are asking, do not show cleavage of RO bond. Here RO bond is not cleaved. Which one is cleavage takes place here? OH bond. So this is option 4 is correct answer. Next one, question number 7. See the question number 7 here. What is the question? Replacement of OH group in alcohol by Cl cannot be carried out. Means OH is not replaced by chlorine. In which of the following? They are asking. So alcohol general formula I will write here, ROH plus what it is their first option? PCl5 they have given. In this one OH is replaced by which one here? Chlorine. What you are getting? RCl I have already written same reaction. So OH is replaced by chlorine or not? Yes. And you see, and second option, option 2, and ROH reacted with the SO2Cl2. What is the difference you see? SOCl2 is a thionyl chloride. SOCl2 is a thionyl chloride, but here what it is? SO2Cl2, it is a sulfuryl chloride. In all cases, what is the nucleophile here? And here this PCl5 provides the Cl minus, and here also nucleophile, and Cl minus here nucleophile. Which reaction it is? Nucleophilic substitution reaction. Clear? But means 2OH2 replaced by the halogen, and halogen should be here nucleophile. But if you see SOCl2, SO2Cl2, if you heat this compound, it gives SO2 plus Cl2. It cannot provide, it provides what it is? Chlorine molecule, not the Cl minus ion. So that's why, and it is Cl2 it provides, Cl2 will not replace the OH. Which one replace? Cl minus, nucleophile required. So it cannot produce the nucleophile, it produce the only chlorine molecule, not the chloride ion. So that's why, and this reaction will not takes place. And next one, you already know, third option, ROH and PCl3. Here also what you will get? RClOH is replaced by Cl minus ion, that is chloride ion. And next one here, ROH plus SOCl2. Here also what the reaction? You will get RCl plus SO2 plus HCl. In all cases you see here, what happened? OH is replaced by nucleophile, that is what it is, chlorine. So, but here it cannot provide the nucleophile, it provides only chlorine. Chlorine will not react with the alcohol. That you see the question number 4 we have already discussed. Silent mode. Question number 8. Question number what it is here? 8. Clear? So, what is the question number 8 here? The missing structure A and B in the reaction. They have given reaction here. They are asking, and A and B they are asking. Clear? A and B. What is the structure of A and B? So now what the given first one is RCH2 CH2OH. Which alcohol it is? Primary alcohol. Now you already know they have given here Al2O3 and 350 degrees centigrade. Yesterday we have already discussed. Clear? So Al2O3 at 350 degrees centigrade, alcohols are converted into alkenes, intramolecular dehydration. If Al2O3 and 240 to 250 degrees centigrade, then it is again dehydration, but intermolecular dehydration. Ethers are the product there, and 350 means alkenes are the product. They have already given, and CH double bond CH2, that they have already given. Now, and this is third. Next what they have given? Ozonolysis. O3 and first O3, and after then here zinc H3O plus. Ozonolysis this is. You might have studied in ozonolysis in the first year. So how to write the products in the ozonolysis? Simple. Where the double bond is there, break the double bond and put one oxygen to the carbon, another oxygen to the another carbon. That is the how to write the products in the ozonolysis. Where the double bond is there, you break that double bond and put one oxygen to the one carbon, another oxygen to the another carbon. Then what the compound you will get? You see RCHO plus what you will get? HCHO. This is the products. These are two products. They have given RCHO, they have given, but here they kept A. This is the A. What is the A here? HCHO. Clear? Next one. They mentioned RCHO. They mentioned here only RCHO is reduced. It is what it is, reduced. You know, aldehyde reduction. What you will get here? Alcohols. AAA process you already know. What is the AAA process? Clear? Alcohol, primary alcohol. Oxidation you will get the aldehyde. Aldehyde oxidation you will get the acids. Clear? And reverse. Acid reduction, aldehyde. Aldehyde reduction, alcohol. So what it is? Reduce means you will get the primary alcohol, that is RCH2OH, and this is the B. But in this one, in your options, they have not given any. You see methanol. This is A means what it is here? HCHO. Option 2 you see. This is what we will call methanol. Methanol means what it is? Aldehyde. Clear? And that is A. And B means RCH2OH. So option 2 is the correct one. Clear? So this is option 2. Next one. Question number 9. Next one is what it is? Question number 9. See the question number 9. So what it is here? On treatment with sodium gives B. A on treatment with sodium, A is treated with the sodium and gives B, and with PCl5 gives C, and with PCl5 gives C. Clear? Next, B and C react together to give, B and C react together gives and diethyl ether C2H5O and C2H5 diethyl ether. Clear? So A, B, C are in order. A, B, C are in order. You see, very easy question it is. You are getting which one here? Diethyl ether. Diethyl ether means, you know, you are getting B and C react and you are getting diethyl ether. Diethyl ether means how it will be prepared, you already know. How to prepare? Break it, because it is a symmetrical. Break any one bond, you will get the C2H5O minus, and another one is, you know, one is ethers are synthesized by the Williamson reaction. Williamson's reaction. Williamson's reaction means, you know, one is product, one reactants are sodium alkoxides and another one, you know, alkyl halide. So then only, and these diethyl ether will be formed. Means what should be the alcohol? A here means A should be here alcohol. Then you see, if I write here C2H5OH, C2H5OH reacted with which one here? Sodium. Then what you will get here? C2H5ONA. This is the B. And same reacted with PCl5, you will get C2H5Cl, alkyl chloride, and here sodium alkoxide. B and C both react and gives which one? Diethyl ether. Diethyl ether is coming means here one should be sodium alkoxide and another should be alkyl halide, because PCl5 is there, alkyl halide, and sodium is there, sodium alkoxide. Both will combine and gives the diethyl ether. Clear ma? So that's why, what is your compound here? First one, A is a ethyl alcohol and B is a sodium ethoxide and C is ethyl chloride. So your option is option 3 is the correct one. Next one, question number 10. Which alcohol do not give ketone on oxidation? Which alcohol do not give ketone on oxidation? We already know. And which alcohol oxidation gives ketone? Primary alcohol oxidation gives aldehyde. Secondary alcohol oxidation gives which one? Ketone. Means you have to identify here which alcohol do not give ketone. If secondary alcohols are there, they give ketone. Other than secondary alcohol, that means you have to find out other than secondary alcohol what is there here. First one is isopropyl alcohol. You know what is the isopropyl alcohol? This is isopropyl alcohol. Clear ma? So this is isopropyl alcohol. If you do the oxidation, you know it is a secondary alcohol. It is a which alcohol? Secondary alcohol here. Clear? It is OH is attached to CH, secondary alcohol. Secondary alcohol oxidation, what you will get? Ketones. This is ketone. Remove two hydrogens, one hydrogen from oxygen and another hydrogen from the carbon, and when you are removing two hydrogens, put the double bond. That is clear. Next one. Second one is here allyl alcohol. You already know what is the allyl alcohol. CH2 double bond CH and CH2OH. This is a allyl alcohol. It is a which alcohol? Primary alcohol. This is. If it is a primary alcohol, oxidation, what you will get? Aldehydes. So CH2 double bond CH and CHO you are getting. But they are asking which do not give ketone. It is not giving ketone. It is giving which one here? Oxidation. Aldehyde. So your option should be option 2. Next, third one you see. This is the first one and the second one and here third one. Third one what they have mentioned? Methyl ethyl carbinol. Carbinol means CH3OH. Methanol can also be called as a common name carbinol. CH3OH. This is carbinol, but what they have mentioned? Ethyl methyl. This is one CH3OH ma. This is carbinol. Ethyl methyl means one hydrogen is replaced by ethyl, another hydrogen is replaced by methyl. So one is replaced by ethyl C2H5, another one is replaced by methyl. It is also which alcohol? Secondary alcohol. Secondary alcohol means what you will get? Ketones. So it is also gives which one? Ketones. Methyl phenyl carbinol. Carbinol means you know CH3OH. One is replaced by phenyl and another one is replaced by methyl. Methyl phenyl methyl carbinol. So carbinol means what you will get here? Secondary alcohol. It gives the which one here? Ketone. This is also gives ketone. So which one will not give the ketone on oxidation means allyl alcohol. Clear? So that is, you must know what is the formula here, allyl alcohol. Clear? Next one. See the question number 11. The product of the reaction. Easy, we have already studied. So what is the reaction? Question number here 11. Question number 11. So CH3CH2OH. CH3CH2OH, and what they have given here, copper and 300 degree centigrade. Oxidation of alcohol with the copper, action of heated copper we have already discussed. And primary alcohol gives which one here? Aldehyde. Secondary alcohol and with the copper, you already know what is that one. With the alcohol we have discussed. Secondary alcohol, you know, ketones. Secondary alcohol gives ketones. And tertiary alcohol, you know, tertiary alcohol with copper and 300 degree centigrade, you will get the alkene that we have already studied. Clear? This is alkene. This is plus H2O and plus here H2 and here what it is? H2. Dehydrogenation and dehydration. So they have mentioned here primary alcohol they have given, they are oxidized to which one here? Aldehyde. So our option should be option 3. Answer should be option 3. Next one, question number 12. So that's why I am repeating again and again. I am not simply saying copper for prime, you will get aldehyde. Secondary, tertiary also, if once I write and it will be fixed on your mind. So next one is, see the question number 12. A compound X on with molecular formula X they have given. This molecular formula C3H8O. This is the molecular formula. Can be oxidized to compound. X is oxidized to compound Y with molecular formula. This is molecular formula how much no? C3H8O and here C3H6O2. This is C3H6O2 and X is most likely to. X is most likely to. You see the options here. Primary alcohol, secondary alcohols, aldehydes and ketones. Aldehydes and ketones. Clear? So you know that here, and we have taken C3H8O. C3H8O means, shall I write CH3, CH2 and CH2, OH ma? Clear? How many are there? 3 and here 2. Clear? 3 plus 2, 5, 5 plus 2, 7, 7 plus 1, 8. Clear? So why I have written this one? It can be secondary alcohol also. If I write secondary alcohols, OH if I put here, I will also get the C3H8O. But you see, when it oxidizes, and here one oxygen is adding. And also very important here, it is a acid. It is a which one here? Acid. One oxygen is there. You know, suppose if it is alcohol, oxidized aldehyde. Aldehyde means number of oxygen will not be changed. Here one oxygen means here one oxygen. And but further oxidation, acids will form. Acids means one oxygen will be added. COOH. And also here number of carbon atoms are same, you see. Number of carbon atoms are same after the oxidation. Then it is a primary alcohol. I already mentioned primary alcohols. Clear? What it is that one? And primary alcohols are there. Take the primary alcohols and here oxidation with the strong oxidizing agent. You will get the acid. You will get the acid and carbon atoms here are same. Primary alcohol, how many carbon atoms are there? Acid will also have the same number of carbon atoms. If you take secondary alcohol, if you take the secondary alcohol and oxidation with strong oxidizing agent, first it will be converted into ketone. And ketone is there, then bond breaks here when they oxidize it to acids and bond breaks according to the Popov's rule. I already said. You will get acids here, but you know these acids carbon atoms are less than the alcohol. Secondary alcohol means original alcohol. By this I cannot write here secondary alcohol. Why? Why? Because you know this is a prime, because and if I get here, you see, if I take the secondary alcohol, Here same carbon atom should not be present. If it is 3 are there, it should be less than 3. So it is carbon atoms are not changing. Carbon atoms are not changing means it is alcohol is a primary alcohol. And why not here aldehyde? If I write aldehyde, CH3, CH2, CHO. It can be primary alcohol, it can be secondary alcohol, it can be aldehyde. Aldehyde oxidation also, you know, same number of the carbon atoms you will get in the acid. But here, if I write this formula, it is not matching with the molecular formula. See, 3 carbon atoms, 3, and here 5, 5 plus 1, 6. But here how many are there? 8. So that's why our compound should be which one here? X should be primary alcohol. Primary alcohol, if you see this is, if I take CH3, CH2, CH2, OH, do the oxidation. First what you will get? You will get CH3, CH2, CHO. And further oxidation, what you will get? CH3, CH2, CO, OH. And what is the formula? C3H8O and here C3H6O. This is O2. This is the option. Clear? So this is about the question number. What it is here? 12. Option is first one. Next one. See the question number 13. Which of the following reaction does not involve reduction? Does not involve reduction. You see first one. Acid to alcohol. AAA process we have. A and A oxidation aldehyde, aldehyde oxidation acid. So they mentioned acid to alcohol. This is acid to alcohol means what it means? Reduction. Acid reduction aldehyde, aldehyde reduction alcohol. So acid to alcohol means it is a reduction. Aldehyde to alcohol, aldehyde to alcohol, it is a which one? Reduction. Clear? Next, ketone to alkane. Here ketone means CH3, suppose any ketone R, C double bond O and R. If I use reducing agent here, then what you will get here? Alcohol. Secondary alcohol you will get it. And further reducing agent, strong reducing agent if I use, then alcohol will be, you know, reduced to alkanes. Alcohol are reduced to alkanes. Means you see in this one RCOOR is there and it is converted to RCH2 means here oxygen is removed, hydrogens are added. You know, removal of oxygen and addition of hydrogen we will call as a reduction. So that's why. And aldehyde to this compound is a compulsory what it is? A reduction only. This is a reduction. Next one. Alcohol, secondary alcohols to ketone. Alcohols to ketone. Clear here? Alcohols to aldehyde or alcohols to ketone. It is a which one? Oxidation. So it is not a reduction. So option 4 is the correct one. Clear ma? Next one. Tertiary alcohols are resistant to oxidation because I already said primary alcohols are easily oxidized to aldehyde, secondary alcohols are oxidized to ketone, and tertiary alcohols do not undergo oxidation. Why? Because means you know that already for the secondary tertiary alcohols, this is the structure R and R and R and OH. To undergo oxidation, this alcohol must have alpha hydrogen. Alcohol must have which one ma? Alpha hydrogen. Because you know functional group attached carbon we will call as a alpha carbon and hydrogen attached to alpha carbon we will call as a alpha hydrogens. And that tertiary alcohol does not have the alpha hydrogen, so it do not undergo oxidation. Clear ma? But with strong oxidizing agent like concentrate H2SO4, first it will be dehydrogenation, the alkene will be formed, then after then oxidation. But they do not undergo oxidation easily. Why? Because does not have the alpha hydrogen. If suppose take the secondary alcohol R and you know H and here OH is there, alpha hydrogen is there or not? This is alpha hydrogen. So that's why you know here hydrogen and here hydrogen, removal of hydrogen oxidation, and we will get here ketones RC double bond OR. So they primary and secondary alcohol will have the alpha hydrogens. So that's why they can undergo oxidation but not but tertiary alcohols do not. So that is, they do not have the alpha hydrogen atom. That is the option. So first one is the option. Next one, question number 15. Clear? Ethanol on heating with acid, acetic acid, in presence of few drops of sulfuric acid give a smell of, you already know, ethanol on heating with acetic acid. What is the ethanol formula? C2H5OH ethanol formula. Acetic acid formula CH3COOH. In presence of a few drops of acetic acid, H2SO4 acidic medium. You know what is this reaction? Alcohol reacted with the acid in presence of acidic medium gives the ester, that we will called as a esterification. That we will call as which one? Esterification reaction we have already discussed. Acids reacted with the alcohol in presence of acidic medium gives ester, and I said remove the H from the alcohol and OH from the acid. Don't do reverse. So you will get the compound is CH3CO and here OC2H5 plus H2O. So you will get here ester. You will get the ester smell while doing this reaction. So option 3 is the correct one. And the next one, question number 16. Which of the following alcohol do not give iodoform reaction? So very important, I already said this is iodoform reaction. Alcohol to give the iodoform reaction, the alcohol must have the, you know, I mentioned CH3CHOH group. Which alcohol has this group? That alcohol only give the iodoform test, that you will get the yellow precipitate. Clear? And now options they have given, write one by one. Grain alcohol, I already said what is the grain alcohol. Ethanol we will call as a grain alcohol. So ethanol means what is the formula? CH3CH2OH. CH3CHOH group is there or not? CH3. CH2 means what I can write? CH and OH. Shall I write this is? So this group is there or not? CH3CHOH. CH3CHOH. So it will give the iodoform reaction. Next one, carbinol. What is the carbinol formula? Just now only I mentioned. Methanol we will called as a carbinol. Clear ma? So this molecule have this group CH3 directly, OH is there, CH is not there. So it will not give the iodoform test. Rubbing alcohol. What is the rubbing alcohol? I already mentioned isopropyl alcohol. We called as a rubbing alcohol. You see CH3CHOH. CH3CHOH group is present here. So it also gives the iodoform test. Clear ma? And fourth one. And fourth option you see. Option 4. Vinyl alcohol. What it is here? Vinyl alcohol. CH2 double bond. CHOH. Clear? So this actually undergo tautomerism. Clear? So what is the tautomerism? You have already studied in the first year. Clear ma? So here H will be there and this bond electrons will come here and this bond electron will go here. Then you will get CH3 and CHO, or you can simply say here CH3 and CH double bond O, aldehyde. Clear? So this is the compound. When these aldehydes are there, alcohols, what is the group should be present? CH3CHOH. For aldehydes and ketones, there should be a CH3CO group is present, then they give the iodoform test. This we will discuss in the aldehydes and ketones. Clear? So that's why when vinyl alcohols are there, they involved in the tautomerism and converted into the aldehydes. So aldehyde are ketones having CH3CO group, they give the iodoform test. So what is your option here? Option 2 will not give the here any reaction. Clear? So that is next one. Which of the following, 17th question. Question number here 17. See the question number 17. Which of the following alcohol does not give red color in Victor Meyer test? We have already discussed about Victor Meyer test. Clear ma? Primary alcohols gives red color, blood red color in the Victor Meyer test. Secondary alcohol, blue color. Tertiary alcohol, colorless. Clear? So that's why red color they are asking. Which alcohol does not give red color means primary alcohol will give red color, other alcohol, secondary and tertiary alcohols will not give the red color. First one, isobutyl alcohol. Clear ma? Isobutyl. What is the isobutyl alcohol? One is isobutyl alcohol, CH3 and CH3 and CH2OH. This is isobutyl alcohol. This is iso group and 4 carbons are there, butyl, isobutyl alcohol. It is a which alcohol here? Primary alcohol. Primary alcohol means it gives the red color in Victor Meyer test. Clear? Next one, second option what they have given. Second option, isopentyl alcohol. Same iso group means CH3 CH3 pentyl, CH2OH. This is isopentyl. It is which alcohol? Primary alcohol. Primary alcohol means it gives which color ma? Red color. So it gives red color. And third option, option 3, diethyl carbinol. Carbinol means CH3OH, diethyl means C2H5 and here C2H5 and CHOH, diethyl carbinol. It is which alcohol? Secondary alcohol. Secondary alcohol means which color it will give? Blue color. So that is the option. Do not give red color means this is. Fourth one, phenyl carbinol. Carbinol means what it is ma? CH3OH carbinol. Phenyl means one hydrogen is replaced by the pH. That we will call as a phenyl carbinol. It is a which alcohol? Primary alcohol means which one it give? Red color. So what is your option means? Option 3. Question number 18. Clear? Methanol and ethanol are distinguished by methanol. Methanol, what is the formula? Carbinol. Methanol, CH3OH. And second one is ethanol. Ethanol means C2H5OH. Clear? So next one are distinguished by first one, treated with Skipp's reagent. Skipp's reagent we will use there for aldehydes and ketones, not for the alcohol. That we will discuss in the next chapter, aldehydes, ketones and carboxylic acid. Treated with Lucas reagent. Lucas reagent we have already discussed, and tertiary alcohols gives the turbidity immediately, and secondary alcohol gives turbidity 5 to 10 minutes or within 5 minutes, and primary alcohols will not give the turbidity. If I treat these two with the Lucas reagent, it is also primary alcohol like methanol, and it is also primary alcohol CH3CH2OH. So both will not give the turbidity with the Lucas reagent, but using Lucas reagent we cannot distinguish. Next one, heating with the iodine and alkali. Heating with this iodine and alkali, iodine plus alkali, NaOH. Have you remembered this reaction? Iodine and NaOH, iodoform test, iodoform reaction. Clear ma? So to give the alcohol iodoform reaction, what is the condition? The alcohol should have the CH3CHOH group, or simply sometimes I will write OH here also, no problem. Yeah. Now methanol, you see, methanol CH3OH, but CH is not there. Methanol does not give the iodoform test, so you will not get the yellow color. But ethanol gives iodoform test. What is the ethanol formula? CH3CH2OH, CH3CHOH. So it gives the iodoform test, and you will get here, CHI3. Iodoform, and this I said this is converted into iodoform, and remaining carbon is converted into acid, one carbon acid Na, and here you will get NaI plus H2. How to balance we have already discussed. This is what is the color of this compound is iodoform yellow PPT. So ethanol gives yellow PPT but not the methanol, so we can easily distinguish. Clear ma? Now treated with chromium in dilute H2SO4. Chromium, oxidation, alcohol, this is oxidation, gives the what you will get, aldehyde, and this is also you will get aldehyde. And CaRO3 and dilute H2SO4 means it will not stop at the aldehyde stage, acid. It also gives the acid, it also gives the acid, so we cannot distinguish easily. That is. So next one, question number 19. What are the final products of the following sequence of, question number here 19, question number 19. First they have given benzene. What is the benzene here? C6H6. Next they have mentioned CH3CH double bond, and here AlCl3. It is AlCl3. It is what it is? Preparation of cumin. Preparation of which one here? Cumin. You know that here this bond electron, it is a electron donating group. It donates electrons to this carbon. This carbon gives the electrons to final carbon, terminal carbon. Means this carbon is gaining electron, this carbon is losing electron. So what you will get here? CH3 and CH plus and CH2 minus. Clear? So here carbocation is there. This minus will take the one hydrogen, because we will use the acidic medium here AlCl3. So then what happened here? Carbocation will be formed here. Electrophilic substitution reaction. Then you will get the compound here is, means actually not plus, and here it will attack here on the AlCl3. Clear? So that mechanism not required for you. And what it is directly, you can write CH3 and CH double bond CH2. So what will happen? Electrophilic substitution reaction. You know here what is there? Benzene. So benzene electrophilic substitution, it is a electrophile. Then this bond electron will move towards it. So then what the compound you will get? You see, you will get and bond here directly. After that resonance, everything will be there, and CH and CH3 and CH3. What is the name of this compound? Cumin. What is the name of this compound? Cumin. That is cumin. Then it is treated with which one here? Oxygen. Clear? Then what you will get? We have already discussed from here. You will get the compound is oxidation, aerial oxidation. You will get the cumin peroxide. Have we discussed or not, ma? Cumin peroxide. Clear? And cumin peroxide, after then hydrolysis, what the product we will get? We will get the product is here phenol and plus acetone CH3 CO CH3. This is preparation of phenol from the cumin. So what is your option now? Option 2 is the correct one. Phenol and A is no. A means here cumin. A is cumin and B is here cumin peroxide. Cumin peroxide. What is the final product? Phenol and acetone. So option 2 is the correct one. So in the same way, see the question number 20. So by which of the following reaction phenol can be prepared industrially? Clear? So you know Raschig process, it is used mainly for preparation of aromatic halides. If you get aromatic halides, we can convert easily into Dow's process. We can convert it into phenols. Dow's process, phenol can be prepared. Cumin oxidized and product is treated with dilute H2SO4. You will get which one? Phenol. So all of the above. 24 is the option. Clear? It is the answer for that question number 20. Clear? What is the Raschig process? I will say here. So it is, benzene when treated with the HCl plus of O2 and in presence of CuCl2, and almost you have to take 500 Kelvin temperature. Clear? Then what the compound you will get here is, see now, you will get the compound here chlorine. See here one H and here one H, two hydrogens, and here one oxygen. Of O2 means one oxygen removed as a H2O and Cl will be added here. After then, we can use here NaOH hydrolysis. Clear? Dow's process you can use, or if you wanted to put directly and water at 425 degrees centigrade, you will get the what it is here? Phenol. And this process up to here, preparation of chlorobenzene. Clear? From which one? Benzene. That we will called as a Raschig process. Clear, ma? Preparation of preparation of alkyl aryl halide mainly chlorobenzene from the benzene. By using HCl and oxygen in presence of copper sulfate, we will call it as a Rossig process. Clear? Next one. Question number 21. Clear? The compound obtained by heating cumin peroxide with dilute H2SO4. You know, just now only we have mentioned. This is what it is, cumin peroxide. What is the formula of cumin peroxide? And this is carbon and O and OH, and this is CH3. And if you hydrolyzed in presence of acidic medium and heat it, then what the compound you will get? You will get the compound is phenol plus what it is? Acetone. CH3CO, CH3, acetone. So main is phenol. So next one. Question number 22. Option, your answer is here, option 1. Question number 22. This is from the first year question. Benzene is, you know, oxidation. What it is? The product of reaction benzene with oxygen in presence of B2O5. It is question from your first year concept. What you will get here? Malic anhydride. This is the compound plus CO2 also will be removed. Clear? 2 moles of CO2. So what you will get this name here? Malic anhydride. So if you see in your first year textbook and first year, you might have studied about this question. Clear? Next one is Dow's process used in the industrial preparation of phenol is. You know what is the Dow's process? Clear? And preparation of phenol from the, which question it is? Question number 23. What is the Dow's process? Preparation of phenol from the chlorobenzene treated with which one? NaOH. You can write in this way. Yeah, NaOH, and you have to maintain the drastic conditions because you know, and haloarenes will not involved in the nucleophilic substitution reactions easily because it is a partial double bond character. So you have to maintain here drastic conditions. 623 or, you know, 320 atmospheric pressure. Clear? This is Dow's process. Then what you will get here? You will get the compound is phenol. After then, this is the first one. Second one, what we have to do? Hydrolysis. Then you will get the which one here? Phenol. Clear? But they mentioned here, you see the first one, NaOH means NaOH. When chlorobenzene they have given NaOH and CuCl to 300 degrees centigrade means they used here catalyst. When we use it, the catalyst automatically we need not to maintain the drastic conditions. So we can maintain directly here 300 because catalyst it increase the rate of reaction. So that's why you need not to maintain the high temperatures there. You can put 300 degrees centigrade, then the reaction will give and phenol. So option 1 is the correct one. Clear? Next one. See the question number 24. Question number 24. Clear? What is the question number 24? Which of the following will not be soluble in sodium carbonate solution? What it is here? Sodium carbonate solution. Clear? Or you see, we can simply write here first one means sodium carbonate solution. Which one will not be soluble? They are asking. Not be soluble. Yeah. You know that sodium carbonate is a base. Clear? So to involved in the means to dissolved in the base. And the compound should be more acidic. If it is very less acidic, it won't be reacted with the strong base. I already mentioned. Suppose simply I will give one simple example here. Phenol is there and alcohol C2H5OH. This is which one here? Alcohol. Both are acidic because it can give the H plus ion and it can also give the H plus ion, but it will react with the NaOH but not ethanol. Ethanol will not. This reaction takes place, but here reaction will not take place. Ethanol will not react. Yeah, with the sodium it will react, but what not the NaOH, because NaOH is strong base to react with the acid, and this should show some more acidic character. Then only base reacted with the acidic acid. But here this acidic character of the ethanol acidic character of ethanol is not enough to react with the base. Why? Because this ethanol, it cannot turn the even blue litmus to red litmus. Clear? That much weak acid here, so it won't react with the NaOH. But phenol compared to ethanol, it is more acidic, so that's why it will react with the base and it gives the sodium phenoxide. So this is the one reaction to distinguish between the phenol and ethanol. In the same way, if I take here phenol and acid, acids are more acidic than the phenol. Acids are more acidic than the phenol. It won't react with sodium bicarbonate. No reaction. But here acids will react with the sodium bicarbonate, or you can say sodium carbonate, and the reaction will take place. This is sodium bicarbonate and phenol. Sodium bicarbonate, it is a base, and here it is a phenol is, it is less acidic. It is a weak base and it is less acidic, so that's why. And it is more acidic. ROOH is a more acidic. It will react with the NaHCO3 but not the phenol. So this is the sodium carbonate or sodium bicarbonate, mainly sodium bicarbonate used to distinguish phenol and acids. Acids easily will react but not the phenol. So this is the, so means to react with the sodium carbonate or sodium bicarbonate, the acid should be more acidic. Clear? And this acidic nature of the phenol is not sufficient to react with the base. So based on that concept, first one you see, what is the option they have given? So first option they have given OH and NO2, NO2 and NO2. This is what it is, picric acid. These all are which groups? Electron withdrawing groups. Electron withdrawing groups increases the acidic nature of phenol. You already know. So it is more acidic. It is what it is, more acidic. Clear? And next one, acids you already know, it will react with the sodium bicarbonate and also sodium carbonate. So it is more acidic, so it will react with the sodium carbonate. And the next one, acid more acidic than the phenols, so it will react with what it is, Mahia, sodium carbonate. And next one, phenol is less acidic, so that's why it won't react with the Na2, means it won't dissolve in Na2CO3. And benzene sulfonic acid is more acidic, so it will dissolve in Na2CO3. Clear? So our option is here phenol. Next one, 25th question. The most suitable method of separation of 1:1 mixture of orthonitrophenol and paranitrophenol. Question number 25. Question number which one, ma? 25. Orthonitrophenol and paranitrophenol. Clear it is? Previously we have discussed, this is orthonitrophenol, and second one is which one? Paranitrophenol, OH and NO2. So how we will separate these two mixtures? We have already discussed by using the steam distillation, because it is a volatile and it is non-volatile. Volatile and non-volatile means you already know. We will separate by using steam distillation. So your option is here, option 4. Distillation they have mentioned, but not distillation. Steam distillation you have to add there. Clear? Next one. Question number, you see, question number 26. Question number what it is, Mahia? 26. See now, what is the first one here? Phenol they have given. Clear, ma? Phenol plus, it is reacted with concentrate H2SO4. It is reacted with what it is, Mahia? Concentrate H2SO4. So then what you will get here at 100 degrees centigrade. At 100 degrees centigrade. And it is a sulfonation. I already mentioned it is a sulfonation. Sulfonation of phenol depends upon temperature. You will get sulfonic acid, phenol, and the 2-hydroxy benzene sulfonic acid and 4-hydroxy benzene sulfonic acid. But I already mentioned in the PU part, when 25 degrees centigrade, then ortho product is the major. At 100 degrees centigrade, para product is the major. So 100 degrees centigrade they have clearly mentioned, so that's why OH and SO3H. This is the product. Clear ma? And B, next it is treated with the bromine and water. What it is here? Bromine and water. You know, this is already para position is already occupied. Bromine in water means 2, 4, 6 tribromophenol you will get it. But one position is, you know, already it is occupied. So that's why you will get the compound is here and OH, and here there is a bromine, and here SO3H, and here there will be a bromine. But you see, if they give in the option, this is also OH, Br, Br and Br. If they give, this is also answer. Why? Because I already said SO3H is a very good leaving group. When bromination takes place, this group will remove. But in the option, they have not given this compound. So you have to choose this answer, that is option. Next one. See the question what they have given. C6H5OH means it is a phenol. Phenol is treated with ammonia in presence of ZnCl2 and gives A, compound A. A treated with B and gives benzoylide. Yeah? So you know that what is the reaction here? Phenol. Phenol means, and sometimes they will give C6H5OH, this is phenol, treated with NH3 and ZnCl2. You know, ZnCl2 is a catalyst. Clear? Then what happened here? You know, and in this reaction, one H and here OH will be removed as a water. Clear? Like you know, with the Na, chlorine is there here, chlorobenzene with the NaOH, chlorine will be removed and you know, OH will be added. In the same way, it is also difficult to break this bond. I already said, it is not a single bond, it is a partial double bond character. But we used here zinc chloride, drastic conditions we are maintaining. So that's why the CO bond breaks with very difficulty and you will get the compound here is aniline. On the benzene, what the compound you will get here? Aniline. This is. When aniline is treated with one compound, you will get benzoylide. Anylides means the formula, this is, and NH and C double bond O. And if any group is there here, that we will called as anylides. If CH3 is there, acetanilide. Depend upon R, the name comes. It is anylides, these are. You know, benzene NHCO and one group is there, any group that can be, this we will call as a anylides. Clear? And if it is there, methyl group is there, so acetanilide, CH3CO we will call as a, you know, acetanilide. Means RCO group is there on the aniline, that we will compound we will call as a anylides. CH3CO is there, you know, this is acetonilide. If here benzene is there, pH is there, benzoylide, that is the compound. So means, and here from the aniline, this we will called as benzoylide. This is what it is, benzoylide. So this is. If CH3CO is there, acetonilide. Clear? And PHCO is there, benzoylide. Means to the NH, PHCO should be added. How it will be, this reaction takes place, and P, C double bond O, Cl, if I take one H and one Cl will be removed as a HCl, then you will get the benzoylide. So I have to take here benzoyl chloride. What I have to take here? Benzoyl chloride. This we will call as a benzoyl chloride. Acetyl chloride, acetyl chloride, like benzoyl chloride. So this is the reaction. So your option should be option 2. Clear ma? Next one. Question number, your answer is what it is? Question number 2. So which of the following compound undergo hydrolysis most readily by aqueous NaOH to furnish the corresponding phenol? This question we have already discussed here in the haloalkanes and haloarenes. What they have mentioned here, NaOH, which involved in the reaction very fast, chlorobenzene, and another one is there. They mentioned here chlorobenzene, and here two methyl groups are there, CH3 and CH3. This is option 1. this is 2, and third one they have given here is, you know, chlorobenzene with nitro group NO2, and fourth one we have chlorobenzene with the 2 nitro groups, chlorine, NO2, and here NO2. In all cases, what is the reaction here? NaOH. NaOH means what it is? OH minus Na plus and OH minus. OH minus, it should react with these compounds. So they are asking in which compound OH minus ion attack takes place easily to give the phenol. You know that here chlorobenzene, it has to attack on the benzene ring and then chlorine should remove in all cases. Clear? But you know benzene is a electron rich and OH is also what it is? Nucleophile. Nucleophile means electron rich. Can it easily attack on the benzene ring here? No. Why? Because benzene electron rich. OH nucleophile is also electron rich. There will be repulsions. To replace the chlorine, and we have to decrease the electron density on the benzene ring. Then on the benzene ring electron density, if you decreases, OH minus ion, it can easily come. Why? Because electron density is less means repulsions less. Then OH minus attack here on this benzene carbon and chlorine will be removed. That is the process. Clear? No? But here, and repulsions will be there. There will be a repulsions. Clear? So here, and you know, this group is electron donating group. It giving electrons to which one? Benzene ring. Benzene is more electron density, and here repulsions more. Now NO2 electron withdrawing group, it withdraw the electron from which one? Benzene. Electron density less, so it can attack. But here you see 2 withdrawing groups are there. Electron density on the benzene ring compared to here very less. So that's why attack takes place and chlorine will form. So this will react very fast with the NaOH to give the phenol. So that is the question number 28. Understand what I am saying? That is the same question we have discussed in the and haloalkanes and haloarenes. Now 29th question you see. An organic compound having the molecular formula, they have given organic compound C8H10O. On being heated with iodine and NaOH, being heated with which one? Iodine and NaOH gives yellow precipitate. Which precipitate it will give? Yellow PPT. It gives yellow PPT. So the compound is expected to be, you already know what is this reaction. You know compound iodine and NaOH. What is this? Is iodoform reaction. Why yellow precipitate is coming? Yellow precipitate means what it is? Iodoform, that is. This is the iodoform reaction. You know that two they have given in the options, all are alcohols only. Options you see, by options you can identify. All are alcohols only. Means you know that alcohol to give the iodoform reaction, this group must be present. Check it in which compound the group is present. In the first one, CH2, first compound, there is no CH3CHOH group. Second compound also, there is no CH2OH is there, but CH3 is not there. And third compound also, there is no CH3CH. Fourth compound you see. What is the fourth compound? This is the fourth compound on the benzene ring. You know what is there? CH, OH, and which one is there? CH3. This group is present or not? So that's why it will form the iodoform test. Yellow compound means that C8H10O is this compound, not the remaining. Clear? That is next question. Question number 30. For making, then so many times we have discussed this compound. For making, and you know CH3, CH3, CH3 and O, C2H5. This is diethyl ether, tertiary butyl and ethyl ether. Clear? So now to prepare this compound, what is the ideal combination? Ethers will be prepared from the Williamson synthesis. Williamson synthesis follows the SN2 mechanism. SN2 mechanism means the alkyl halide should be smaller. Clear? So this is alkyl halide, this is sodium alkoxide. So what is the ideal condition is, so many times we have discussed ONA and plus C2H5Cl. This is the ideal condition to form what it is here, ethers, this ether. Question number 31 you see. Mixed ethers will not be formed in this reaction. Mixed ethers will not formed in this reaction. means in which reaction ethers will not be formed, they are asking. Clear ma? You see, I already given for preparation of ethers. In the preparation of ethers, so mainly Williamson's reaction we have discussed. Clear? Some other reactions also there, but which are not given in the NCERT textbook. So those reactions here, first one is, I am explaining reaction with alcohol, reaction with, what it is here, alcohol reaction with diazomethane, diazomethane. This is one of the method to prepare the ethers also. Clear ma? So what is this one? You know alcohol. Alcohol means ROH. Diazomethane, CH2N2 in the presence of acidic medium, then you will get the compound is ROCH3. Simply what it is here, this CH2 will be inserted between the oxygen and hydrogen. See, this is ROH. Now you put the here CH2 in the middle, then CH2H, then what will happen? CH3, that only I have written, plus what it is here, N2. Clear? So this is the one of the preparation of which one here, ethers. Clear? So how this reaction takes place? Easy. You see now. First one, ROH. You know this is CH2 double bond and N plus and N minus. This is the reaction. It is positive charge, so that's why this bond electrons moves towards the nitrogen, because nitrogen positive charge, highly electronegative, positive charge means unstable. The electron moves towards the nitrogen. Now carbon is losing electron, nitrogen is gaining electron. Carbon losing electron means which charge acquires? Positive charge. And you know here which oxygen is having lone pair of electron. It attack here positive charge. These electrons moves towards the nitrogen. Then what the compound you will get? RO, and oxygen is losing electron, positive charge, and CH2 and nitrogen, and here N minus, and positive charge will be neutralized. This is the compound. Clear? Now in this case what happened here? On the oxygen there is, you know, a positive charge unstable, it will take the electron from the hydrogen. So RO and CH2 and N double bond, you know, N minus, and here what is removed here? H plus. Clear? Now what happened? You see, these bond electrons will move because nitrogen is very good leaving group, so it wants to move, remove. So that's why bond electron comes here. Nitrogen is forming how many bonds here? 3 bonds. So this bond electron will come towards the carbon. Then what the compound you will get? RCOCH2 minus. Now already here which one is lost? H plus. That H plus is taken by CH2. You will get ROCH3. You are getting which one here? Ether. Clear? So this is the reaction. Sometimes what they will give, simply you can, any reaction if they give CH3, CH2, OH is treated with the diazomethane, then write the product. Simply put the CH2 in the middle, then what you will get? CH3, CH2O, CH2H, CH3. This is the one preparation for the ether.